get out your periodic tables.
Yeah, we're going to label stuff
We're going to label stuff.
on the periodic table.
There's certain patterns in the periodic table.
Wait. What is this gobbledygook?
It's the first periodic table, actually.
Oh.
You don't recognize it?
So this is what that Mendeleev guy is so famous for?
It is.
Man, you'd think it'd be easier to read if he was so smart.
What are you talking about?
Oh, wait, it's in Russian.
It's in Russian. Okay. Oh. Man, he had bad handwriting. No, but it's arranged in a pattern. First off, you need to know this is the periodic table of elements.
So these are basically like the building blocks of all other substances that exist in the universe.
Everything in the universe can be found on that chart in its base form, made up of those atoms. 92 of them occur naturally. They cannot be broken down into simpler substances
and still retain the same
still retain their properties.
As matter.
Every element has a 1 or 2 letter symbol, and that's how you can help easily find it. You'll get used to them, but they don't always make sense. For example, C stands for carbon, but Fe stands for iron.
Yeah, no F in iron, as far as I can tell.
It's definitely not in the English word, but it is in the Latin word for iron, so it's named after that. Fe stands for iron. When there's 2 letters, one is capitalized, one is lowercase. We've got groups on the periodic table. Groups, go ahead and write this down, are sometimes called families, and they are vertical.
So you think of the word family, your own family. Genetically speaking, you share a set of properties with people in your family, which is exactly why we call the groups families, because all the elements in that group or in that family share a set of properties, just like you and the rest of the people in your family.
So group 1, and go ahead and write these on your periodic table. Group 1 is the alkali metals. All those metals have something in common. They share properties.
Group 2, same thing. Those are called the alkaline earth metals, another important family for you to be aware of.
The transition metals are in that little break in the bottom, make up a big chunk from 3 to 12 there. And then the other 2 families we're going to worry about, you've heard of the noble gases and the halogens. For noble gases, you're probably more familiar with. They don't react with anything. They're inert. Maybe you've heard that word. It means non-reactive.
They don't like to associate with the other elements, kind of like the nobles would not like to associate with the commoners.
Kind of snooty.
Yeah.
And then the halogens. We also have another direction, the horizontal direction, and those are called periods.
Notice the nice color coding. You can see what's in each period. Period 1 only has 2 elements in it.
Notice they don't have to be next to each other. They're in the same row. It's a period.
Indeed.
But then look at the island on the bottom. There are no numbers there. And it's just kind of by itself. Why is it by itself? Well, look at the numbers on your periodic table and where they start. Now go up to rows 6 and 7 and find out where those numbers fit together. It turns out it's right there before the transition metals. So that island on the bottom breaks into the periodic table there. So we have groups that are vertical and periods which are horizontal.
We also have the pattern of distinguishing properties of certain elements. And if we look at kind of like the big properties, we've got basically 2 different groups. There's the metals and the non-metals. And then these ones that are highlighted in the different color blue here, those are called the metalloids. They're kind of half non-metal, half metal.
And they're right in the transition where the 2 meet. They just have properties of both. Most of the periodic table, you'll notice, is metals.
Yes, so even if you look at it in this perspective, the elements over here farthest to the left are the most metallic. The elements over here farthest to the right are the most non-metallic.
So real quick, let's look at some properties of metals. We'll learn some vocab words here. What do you know about metals? Well, they conduct electricity. That's probably that's an important one. All your copper wires, your computer wires, computer parts, all of those things in electronics are usually made out of copper because it's a really good conductor. Electricity flows through them. You don't want to play golf in the rain or in a lightning storm, for instance. Nonmetals then would be the opposite. If you would like to make a list of nonmetals, they don't conduct electricity.
I'm just going to write don't conduct here in an effort for saving some space.
Don't conduct.
Maybe running out of space.
And that actually goes with heat as well, if you just want to write electricity/heat. Metals conduct heat really well. If you've ever put a pan in the oven and touched it, it's hot.
Yeah, generally you're going to use metals for cooking because it allows the heat to transfer and it conducts that heat. Whereas something like
a silicone baking sheet?
Exactly. You get silicone baking sheets, which really don't conduct heat very well.
So you can take those out. You can touch them. They're not going to get too hot. Make sure it's
Nice.
one you can put in the oven, though.
Metals also, one of their properties is that they're malleable. And this is kind of a big deal as far as their properties. Malleable
Means bendable.
Yes.
It's bendability. You can take a copper wire and you can curl it up, bend it, twist it. You can do whatever you want. Metals, they'll bend. Sheet metals will bend. If you're really strong, you can bend a nail with your bare hands. And nonmetals, they don't bend. They're pretty brittle. They break. Think about your pencil lead. That's actually just carbon. So carbon is a nonmetal. If you were to try and bend one of those pieces of pencil lead, you would break it.
Nice. And then another property of metals that makes them very, very useful for us is that they are ductile. Basically means that they can be drawn out into wires.
Oh, they can be shaped.
It's kind of like malleable, but specifically referring to the fact that they can be put into wires. Non-metals, brittle, so they're not going to be ductile either.
Not ductile.
Yeah.
Always the opposite. Metals are generally solid versus non-metals, which are generally gases.
Anything about metals reactivity?
With acid.
Okay, yeah, react with acid.
They do react with acid.
Metals react with acid.
Metals are solids. Non-metals are usually gases. However, there are two liquids on the periodic table. One of them is bromine.
Oh, sorry. I was going to the wrong spot. Going to the next one. We'll put bromines right here.
That's a liquid. One non-metal. And one of them is mercury. Liquid metal. So one of each. They can be liquids, but generally solids and gases. Those are the only two liquids. Another trend is the atomic radius. How wide the sphere of the atom is. Be very careful. This one defies common sense a little bit.
Basically, as you go from left to right across the periodic table, the radius gets smaller.
Now that doesn't make sense because look at the row 2, period 2. The number there starts out, that's number 3, lithium. If you go all the way to the right, neon is number 10. 10 seems bigger than 3.
Most
and that's
of the time.
True.
Yes.
As far as that number goes, neon is bigger. But as far as the size goes, the left side of the periodic table is the bigger side. Lithium is bigger than neon. So the row going across is really confusing. Going down, that makes sense.
Yeah.
The numbers get bigger in that case. Every row you add a layer like an onion. Onions have layers. The periodic table has layers. Every time you add a row, you add a layer of electrons, and it gets bigger and bigger.
Nice. Always welcome when there's a Shrek reference.
Yeah. The bottom left, big circle there on francium, that is the largest element in the periodic table.
It's actually not on this picture for some reason, but...
No, it was just too big.
Yeah, they couldn't fit it.
It couldn't fit on the
It's
picture.
like the sun.
Diatomic molecules. This last one is incredibly important. You will see this in every chapter on both your semester and final exam. Some molecules...
Oxygen and nitrogen, for example.
Naturally come in sets of 2. Oxygen in nature does not exist by itself as a single atom. It prefers to be a molecule, or a diatomic molecule. Now look at the prefixes there. What do you suppose a diatomic molecule is?
From our knowledge of Greek prefixes, extensive knowledge that we got from English class, di means 2.
2.
So 2 atoms in the molecule.
A 2-atom molecule. There are 8 of them. And they make this really cool word. This was taught to us by a German exchange student. You can remember the symbols for all 8 diatomic molecules. It is Honkel-Briefat. Notice some symbols are big, some are lowercase, for the different elements to break them apart.
Nice try. Forgot the I.
Honkel-Briefat. Hydrogen, oxygen, nitrogen, chlorine, bromine, iodine, fluorine, and astatine. Honkel-Briefat with a lowercase t because astatine is A-T, big A, little t. Well done, Giacomo. Honkel-Briefat.
Doesn't look like a kindergartner wrote this.
All the other atoms on the periodic table are single atoms. They are by themselves. They exist in sets of 1.
So these are all our diatomics. See, there's only 8 of them, so you only have to memorize 8.
Or just memorize a word, Honkel-Briefat.
Or just memorize a Honkel-Briefat.
If you're a visual person, we've got another way to remember it. The lucky 7 plus 1, they form a 7 on the periodic table. All the halogens.
7 of them in the 7.
7 of them in the 7, the lucky
Crazy.
7.
And it starts at number 7.
And it starts at number 7. That's incredible.
And sometimes this is called group number 7 right here, the base of it.
7 over to group 7, lucky 7, nitrogen, oxygen, fluorine, chlorine, bromine, iodine, astatine, all the halogens, and then way over there to the left, hydrogen.
Hydrogen's basically your exception to everything on the periodic table, so we've got our lucky 7.
And hydrogen.
And hydrogen.
So lucky 7, you can remember it either way, but those are the diatomics. Make a note of it. They are important.